Colby, 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 math.com.
Today you received your first weekly computation assignment. You can see that it's due next Wednesday, September 4th. The day before that, next Tuesday, I'll explain to you how you grade it, score it on your own. But for right now, just work on completing this exercise. It's not due a week from today because it's going to take you a week to do it. It's due a week from today so that you'll have a time to spread it out over several days if you choose, and so you can get it done with your other homework load, and it shouldn't be a problem. Just do a couple problems a day, or if you want to do it all now and get it out of the way, you can do that. But for each type of computation, there's only one problem. Over here, when we're practicing integer operations, there are one of each type, but once you know how to do those, they don't take long. If you don't know how to do them or any of these problems, don't forget you have the computation resource on your favorite website. Just go there and look at that icon, and it'll teach you how to do these type of problems. So these 12 problems are due next Wednesday. If you have any questions, you can of course ask on the discussion board or email me or ask in class. Today we learned about stem and leaf plots. We're going to construct a stem and leaf plot on this problem and then use it to answer some questions. This data represents the percent of free throws made during basketball games. And these free throw percentages are unorganized. It's hard to tell where the minimum is, the maximum. It would be hard to find the mode without organizing the data in some way. We've looked at line plots. That would be a good way to organize this data. Stem and leaf plot is another good way. Just writing the data in order from least to greatest would work, but with such a long list, you really want a more compact graphical display, and so we're going to do stem and leaf plot. As I look at these numbers, you see some 50s, 40s, 70s, 39, that might be the least, but then as you continue to scan, you see 24, so that's our minimum piece of data. And so our first stem will be at 2, and this is how I make a stem and leaf plot, and the leaf will be 4. The least significant digit are the digits in the ones place, so those are the leaves, and so the stem will tell us how many tens we have. We've done 24. Now I look for anything in the 30s. There's a 39, and that's the only one, so it's our next piece of data, 39. The 40s, I have quite a few that are in the 40s. So we have 40. The least would be, I missed the 41, and I also missed the 46. So we have 41, and done with that, I see no 42s, but I see 2 43s. Now, resist the urge to place a comma between these digits. That's not the convention. You don't need any commas, semicolons. You just need to put 2 3s, because that tells the viewer that you have a 43 and another 43. Each one of these leaves indicates another piece of data, so there's no reason to separate them with commas. We have no 44s, but I have a 45. If memory serves, yeah, there's 2 46s. I've done the 45. I have 2 46s, so show the 6 twice, and then a 47. This data was, while unorganized, was presented in a rectangular array, 5 by 4 array, so we know we have 20 pieces of data to start with, so that when we complete our stem and leaf plot, we'll count the leaves to make sure we've maintained that 20 pieces of data, haven't skipped anything or written anything twice. Now we're in the 50s, several 50s. 53 looks to be the smallest of them, followed by 55, 56, 57, 59, so 5, 6, 7, 9. In the 60s, we have 60, 64, and 66. So 60, 64, and 66. We have 2 70s, 72 and 79. and 1 in the 80s, 86. And let's count the leaves. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 3 more is 17, and 3 more is 20, and that's what we expected. I'm going to prompt you to pause in a minute, but I just want to mention one extra thing really quickly. Don't write this on yours, just follow along. If we had one more piece of data and it was 100%, here's what our stem and leaf plot would look like. We would put a stem for 9, even though there's nothing in the 90s, and then our next stem would be 10, because 10 tens is 100, with a 0 in the ones place. And so we would show that gap in the data. There, in other words, there's no 90s, but there is one piece of data at 100. It kind of shows an outlier. It shows a gap in the data. It represents those gaps in data and outliers the same way a line plot. I mean, different way, but the same idea. And so, in order to not cause any confusion, I'm going to attempt to erase these, but I just wanted, that's not how you do it. Actually, that'll be fine. Just realize that that's our stem and leaf plot. What I'd like you to do during the pause is think about, I made an error on the stem and leaf plot on purpose, or more accurate would be to say I made an omission. So during the pause, think about what the omission and what we still need to include in this stem and leaf plot, and then try to answer the remaining questions, and then come back after the pause to see how you did.
Paused.
Okay, the omission I made was to not include a key. We always need a key in any stem and leaf plot. I messed with all my settings accidentally here. So here's our key. You could take any piece of data. I'm just going to use the first one. That just shows the viewer that the leaves indicate the ones digit, and the stems indicate how many tens you have. Okay, so we've done this. The next question says, in how many games did Sean make at least 60%? So at least 60% would be greater than or equal to 60. So how many of these pieces of data are greater than or equal to 60? Well, there's a 60, 64, 66. We can basically just start at the 60 and count how many leaves are greater than or equal. And there's 1, 2, 3, 4, 5, 6. So there were 6 games. What is the median percent of scoring free throws that he made per game? We can find the middle number now that our data is in order from least to greatest. But before I do that, I'm going to skip to the mode, because that's the next easiest thing to answer. The mode is the number or numbers that occur the most. 24 only occurs once, as does 39. But we see that 43 occurs twice, that 46 occurs twice, and no other pieces of data occur twice or more than twice. So we have 2 modes, 43 and 46. Remember, you could have 1 mode, you could have 2 modes, you could have 18 modes, or you could have a data set with no modes. If we have 2 modes, that's called bimodal. To find the median, we want to find the middle number. And I could start crossing off the least and the greatest and working toward the middle, but that will obscure my stem and leaf plot. So instead, I'm going to do this. We know we have 20 data points. So I have 10 on the low end and 10 on the high end. Exactly split. And so the 10th and 11th data points will be in the middle. And so if I count the 10th, starting from the lowest, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 53 is the 10th, and 55 is the 11th. So if 53 and 55 are in the middle, the mean of those two, or the number directly in the middle of those two, the midpoint would be 54. So that will be the median of this data set. I should include my units, 54%. I should have included my units here, 6 games. If we're doing a problem with context, we should always include the units. I hope that helped on that homework problem. I'll see you in the morning.